So I don't really have any major updates. I think on the practical side, we have the per validator wallet code tested, but they found in production that there's a replay bug, so they're working on that. It's really interesting how Casper is not the bottleneck, but that cost accounting is a much bigger bottleneck right now than Casper is. And I think that will probably be true for quite some time. You guys understand what I'm saying? You grok?
Yeah.
Cool. We have some good news, which is that we have one of my colleagues from Imperial College is going to start reviewing the ladle algorithm that Mike and I are putting a draft together of. So that's really good news. I sent her a link last night, this morning, and we'll see what she says. So in terms of the ladle work, I think what we have left to do is to, on the one hand, expand the algorithm to include nominality. So, all the examples that we give in the paper don't involve nominal phenomena. Now, it's possible to there is such a thing as a nominal Levere theory. The one thing that's not clear is whether or not nominal Levere theories look like monads, because the value of a Levere theory is that they're a front for a monad. The question is whether or not a nominal Levere theory also corresponds to a monad. So not sure about that. And then Christian Williams has been looking at Marcello Fiore's higher order abstract syntax stuff. So we should be able to get the nominal phenomena covered, but that's something that has to be done before we can call the whole algorithm complete. And then the other thing that we want to do is to build a category that corresponds. So again, following this monadicity idea, there's a category where the monad lives, and then there should be another category that where the logic lives, and then we want the ladle algorithm to be a functor between the two categories. So Mike and I are going to be looking at that. That's and I'll feel like we've really sort of got that thing at the highest possible standard of quality when we have that aspect of the semantics. So that's kind of the work left to do with ladle. I can also mention, so just before I go any further, let me just check and see if there are any questions about that.
Well, maybe if you can say a few words about what is the challenge for nominal theory.
For nominality, so there's not, like I said, there's a couple of ready-made technologies. There's actually several ready-made technologies. I can use reflection to provide a supply of names, and once you have a supply of names that has interior structure, then it's much easier to define a bunch of maps. But that still doesn't account for alpha equivalence. So in order to capture the phenomena of alpha equivalence, there's a requirement. So either you want to use something like Gabay and Pitz's work, which then Clausen lifted to nominal Levere theories. But see, the thing that Clausen didn't do, and so he's got a pretty decent account of nominal Levere theories, which we could just plug in. But the thing that he didn't close the loop on is whether or not a nominal Levere theory corresponds to a monad. Right. So, I mean, the point of using a Levere theory is because it corresponds to a monad, and like the whole, like the name ladle says logic as a distributive law. So it's a distributive law between two monads, right? But if you add nominality, so you get this nominal Levere theory, but you don't have a monad behind it, then it's less compelling in a certain way. I mean, I mean, at the end of the day, I don't really care if it's I mean, the point is to have an algorithm that generates the type systems, but it's much nicer if that algorithm is also, incredibly gorgeous because it's just derives from a distributive law. So that's the challenge on that side. Now, with respect to the higher order abstract syntax, I confess that I actually I like that approach from an implementation point of view. In some ways better than I like the other approach. It's basically lifting De Bruijn indices to the next level. It's like De Bruijn indices on steroids, or next level De Bruijn indices. That's the way I think about it. Christian may tell a different story, but once but with De Bruijn indices, again, the question is whether or not it you get, when you add that machinery, do you have a monad? So I think it's more likely that we do get a monad in that case. But in either case, we're going to have to check those details. So does that clarify? Does that help?
Yeah. So these approaches are very similar, right? So.
No, they're not similar, right? They're not similar. Oh. But
I mean, they solve the same the problem.
They solve the same problem.
Approaches are different.
Yeah, that's exactly right. They solve the same problem, but they solve them in different ways. And to the best of my knowledge, no one has actually done a very fine-grained comparison to. So that would also be useful for the community, is just to have a really fine-grained comparison of the higher order abstract syntax work of Fiore and the. So that's so no one's ever done that, and it would be really cool if they did that. I'd like to see that happen, just for my own edification, just the completeness of my understanding. And then and then the other thing is, of course, to build a category at the level of the logic. So that's it ought to work. It should be relatively straightforward, but I don't know. I don't know. If there's some surprises lurking there. So if you want a little bit of brain candy, I have been watching Arkani Hamed's lecture series that he gave in the fall of 2019. At Harvard Physics, where he's looking at he's looking at a combinatorial presentation that gives rise to a lot of the phenomena that's consistent both with quantum mechanics and general relativity. So he's looking at it almost entirely from the scattering amplitudes, the so-called S matrix stuff. But he's looking at it in a more combinatorial way. So he wants to be able to actually calculate amplitudes. And that's really, it's very compelling. It's very interesting. But the more combinatorial the solutions get, the more likely it is that you can encode them rather directly in process calculi. So as I was thinking about this, I realized that I ought to be able to. So there are two interesting pieces of brain candy that showed up. One is that I ought to be able to generalize the work that I did on knots, which is really more of an encoding of graphs, into process calculi, which is well known. It's a well-known phenomena. But anyway, I can take that and encode Feynman diagrams. So I'm pretty I still have some calculations to do, but I'm pretty sure I can encode a lot of the interesting facts about Feynman diagrams in the row calculus. So that's a little piece of brain candy that I'll probably trot out, early next year. It's just some fun stuff that way. And then the other piece is that I'm also pretty sure that I can compose the Knots processes interpretation with the Kovanov homology, which relates knots to spaces of quantum states. So again, I'm pretty sure I can just take the two maps, and compose them in a particular way, to get because the map. Anyway, without going into too many details, I'm pretty sure I can then use that composition to relate row calculus processes to spaces of quantum states, which would be very, very useful, especially if we want to start doing, programming of quantum consensus protocols with sort of, the usual machinery for describing protocols. So again, this is just fun, it's just brain candy. But it's not, nonetheless, it's research that, occasionally gets a few cycles of my attention. And any question about that?
If you can share a few links in Discord, that would be useful related to that.
Sure. I'll put some. Yeah, I'm happy to put some links.
Thanks.
I mean, if you go to YouTube and you search for Arkani Hamed, Harvard Physics, Space Time and Quantum Mechanics, that lecture series is up on YouTube.
Okay, thanks.
And then if you just type in Kovanov homology, the Wikipedia page is a pretty decent explanation. You can go from there all over the place.
Okay, thanks.
I actually got it because Ed Witten gave a talk at the Institute for Advanced Studies on sort of an alternate presentation of the ideas underlying the Kovanov homology. So
okay, great.
Yeah. So, and I highly recommend that talk because it's surprisingly non-technical for Ed Witten. Anyway, that's all I've got this morning. Any other topics we want to cover?
You said that you will have implementation in Agda. So where this will be published first?
I probably will have it. If I'm lucky, I'll have it before the end of the year, but might not be until the beginning of next year. Yeah, but I'm. Next step is I need to install Agda on my machine and start playing around with it.
Okay.
Yeah. But it's. I mean, the one I've already started contemplating. The input format for the Levier theory. Like there's a certain attraction I have to Scala as an implementation methodology because Scala has Kiyama, which is a rewrite system. There's a whole rewrite library in Scala, and I know the principle. So that might be, it might be kind of a shortcut. I don't know how much support there is in Agda for modeling Levier theories or rewrite systems. So I might have to, invent a whole input format on top of Agda for the Levier theory. It's not a big deal. It's just a lot of bookkeeping. That's all.
I see. I was thinking maybe I can learn some Idris and maybe do
sure.
the same
well,
thing.
I mean, yeah, absolutely. I mean, go for it. It's like the paper's clear. I think clear enough. You start with a. I mean, do it for the minimal case first. So you start with just like a single rewrite, a single generator, couple of constants. A couple of identities for the term constructor, and then you generate. You generate the resource theory, which just adds the evaluation context and a couple of extra maps. And then you generate the context theory. And again, it's like, it's all bread and butter. There's nothing fancy there. And then once you have that, then you can define all of the typing rules. So there's not a lot. I mean, it's really incredibly straightforward. The algorithm is really not complicated at all. So yeah, give it a try. I'm sure that any implementation effort will reveal any hidden bugs or mistakes that I've made, which is exactly what we want to do, is expose all of those as quickly as possible.
It's worth a try, yeah. And I'm not sure that I can do it.
Yeah,
I can try.
Well, I mean, really, it's like if you understand how to read the rewrite rule, the proof rules, right? The proof rules are just basically saying, when you get terms of a particular, they're recursive, right? So you start with the axioms. So like, for example, the generator is typed the generator type. There's nothing there, right? That's just the ground. But then the rest of the rewrite rules are all recursive. So if you have some terms that are typed in a particular way, given certain typing assumptions, then when you can form new terms. So you can either run it in a generative way, or you can run it in a recognizer way. So if you run it top to bottom, you're generating. If you're running it bottom to top, you're recognizing. Does that make sense?
So it's like type checking.
It's a type checker. That's all it is. Which means that it's also just a grammar, right? It's type checking and parsing are two peas in a pod.
And these two directions are like type checking and type inference, or
that's correct. That's right. Yeah.
Okay.
Yep, that's correct. Yep.
And when I define the grammar, do I need to translate this with some kind of structure that is some kind of collection, or?
Well, yeah. So you're gonna have to have a set-like collection monad, and then you're gonna have.
It's part of the grammar.
Yeah. It's a part of the type grammar, and therefore it's part of the term grammar too. Eventually. Yeah. Okay. All right. It's whatever.
Thanks.
6 a.m. my time. So I'm gonna jump off, or not 6 a.m, whatever. Almost midnight. I'm totally confused as to what time it is. I'm in Shanghai. I'm going to Guangzhou in just a few hours. So I'll I'll jump off here and go to the dev stand-up in a little bit.
Thanks.
Thanks, Greg.
Thanks, guys.
Good luck.
Sure. Ciao.
Bye-bye.